For today's session, what we are going to discuss is we are going to discuss the different formulas for other nodes which we are actually being given here, and along with those, we'll be including some conditions, and we'll be seeing how the formulas will change when I induce some different conditions. By the end, we are going to include these networks inside an application, say Netica. So this is the application what we are going to download and install. And in this application, we are going to use the Bayesian networks and we are going to apply it. Alright. So this is actually the task for today's session. So here in this particular problem, I didn't put the probabilities. Now, can you say how many probabilities will be there for H?
Only one, sir. That we should.
I. Why? Because they are conditionally independent. They are not dependent on anything. When they will be dependent on anything? When there is an arrow like this and something is on the top as a parent, then it means that H is going to be dependent. Now there is no arrow like this, so H is not an independent class. H is conditionally independent. Say for example over here with respect to E. Now E is dependent on
H and I, sir.
yes. I want answers from everyone. So H and I. So H and I is going to depend on E. Now how many probabilities can be there for E actually totally? How many probabilities can be there?
Two.
Two, sir.
Two, sir.
It is not just two, it is actually combination of H and I. So when there are actually two different dependencies, then for each of those dependencies, if I want to calculate E, then there is actually how many probabilities? Four different probabilities. TT, TF, FT, FF. Right? I have four different probabilities. Am I making it clear?
Yes, sir.
Yes. Similarly, how many probabilities will be there for C? C is conditionally dependent on E. So there can be one dependency. When there is one dependency, true, false. Two probabilities will be there for C. How many probabilities will be there for A?
Two.
Two, right. So let us see some different types of formulas here that we actually discussed from the previous class. If I want to calculate probability of C, how to calculate probability of C? Probability of C is nothing but its dependent probabilities we have to take. C is dependent on E.
Sir.
So probability of C given E into probability of E, this is actually probability from the positive end of E. Similarly, I have to calculate probability of C given, what is it?
E dash.
Yes, E dash or not E, anything like that, into probability of E dash. Right? Now, here probability of C given E may be present here. Probability of C given not E may C given E dash can be present here. But probability of E and probability of E dash may not be present here. So we have to calculate probability of E now. How to calculate probability of E?
Using
Its
H and
dependencies. So probability of E depends on
H.
H comma I
I.
into probability of H cap I plus how many things I totally have? Four different probabilities. Probability of E given, join with me,
Comma
I dash, sir.
into probability of H cap
Cap I dash.
H great plus probability of
H dash comma I into probability of H dash cap.
very good. Finally,
Probability of H dash comma I dash.
E given H dash comma I dash into probability of H dash
Cap.
cap I dash. So this is what we have discussed. And similarly, how to calculate probability of E dash?
Replace with the E with E dash.
Yes, replace all the E with E dash. That's it. So if only in the formula I'll be getting and be given the probability of E only, then how can I get probability of E dash?
1
1
minus.
minus P of E,
Yes,
sir.
I'll take 1 minus probability of E
Probability.
to get probability of E dash. Great. Now, so far, so good. Any doubt is there? Any doubt up to here? Any doubts up to here?
No, sir.
No,
I want answers, score as answers from everyone.
No, sir.
No,
Yes.
sir.
no, sir.
Yes. Now, if I ask a question, that is probability of C given E. What is the answer for this? Probability of C given E.
Sir, P of C minus.
No.
P
Don't
of C
don't don't
minus.
go. Don't think too much and all. Probability of C given E. C depends on E. So probability of C given E in the sense probability of C given E equals true. So the answer will be direct. Am I right? Here itself a probability will be there for E equals true and E equals false. What is the probability for E equals true? I will be taking directly. I will be substituting the answer. This thing I am actually asking. So in MCQ point of terms, a diagram will be given and you'll be asking with probability of C given E. So what you'll be taking? No formula calculations. Directly you can find the probability over here and you can substitute. Yes, am I making it clear? Please answer quickly.
Yes, sir.
Probability of C given
Sir, tell one second.
E equals true. This is actually the meaning for this. So what is the probability of C given E dash?
False.
Probability of C given E equals false. So directly you can take and write the answer. Similarly, if I ask you probability of E given H, what will be the formula for this? Now you have to think what are the dependencies of E. E depends on
H and H dash.
H and I. So now they have said one thing that H alone can be considered. H dash is not required because in the question it is given that H is going to be true. So only thing what you need to consider is I dash. So you need not consider any H dash terms in the formula. So now if you take the formula, probability of E given H comma I into probability of H cap I. Here any H dash is there?
No, sir.
No. So this part is actually accepted. Next, probability of E given H
H comma
comma
I.
I dash. I dash is accepted. Both I and I dash accepted because we don't have any information regarding I. So I need to take both the possibilities for I. Okay. Next, shall I put probability of E given H dash comma I? Shall I put probability of E given H dash comma I? See in
No,
the
sir.
given question, they are asking that they are already say that H is going to be true. So when H is going to be true, I should not take any input that H is going to be false. So this cannot be done. Next, similarly, can I take H dash comma I dash? Can I take this? No. Why? Because H dash should not be included in my thing. So I need not include this. Is it clear? Am I making it clear? Any doubt is there up to here? Any doubt is there? See, answer quickly, pa.
No, sir.
Yes. So the formula for probability of E given H is nothing but probability of E given H comma I plus probability of H cap I plus probability of E given H comma I dash into probability of H cap I dash. Let us go and proceed with other formulas. Now you have to answer this particular thing. I will not say the answer. Right. So understanding that you have understood so far what you have dealt. Now with that knowledge, we are going to discuss something different, right? Now let me ask you a question. Probability of E given not I. Can you say me what will be the formula for this? What is the information that is given? I is going to be
I,
false.
yes, sir. Not true.
So what will be the formula for this? How many additive terms will be there here?
2, sir.
Two. Very good. Because one information is fixed. About E given, what is the thing?
I dash into H, sir. I dash H.
No,
H
no.
comma
Always go with order. H comma. Always go with order. Okay.
H comma I
Comma,
dash.
comma I dash into probability of H
H cap
cap I dash. Because if order is there, then we can remember what is the next point. So probability of
E given
E given,
I dash comma H dash comma I dash.
yes, correct. So this is how the formulas actually being projected, right? No doubts, right? So far,
Sir,
if yes,
sir, we written I bar no, sir, and I is false no, sir.
yes, I dash in the means I is false.
We can take a above formula, sir. Above formula we can take no, sir. H is 2 means same formula we can write here also.
Which one?
P of above, sir. P of E dash H.
Which one?
Yes, sir.
This formula.
Yes, sir.
This
I false.
formula. This
I false.
formula says H is going to be true, and this formula says I is going to be false. For this formula, if you see, I have taken both I as well as I dash into consideration. Here I have taken H and H dash into consideration. If I want to make you more clear, you answer me this question: what will be the probability of E given H comma I dash?
P of E given H comma.
It is a direct thing. Probability of E given H equal to true and
False. I equal to false.
so here both the things are given for you for understanding. There here only one thing is given, other thing is not given. So I have two probabilities for the other entity which is not given either as true or false. If it is given, then I can directly use it. Am I making it clear now? How the probabilities will appear?
Yes, sir.
Yes. Yes. So you can take screenshot. Now what we are going to do is we are going to implement this Bayesian network in Netica, right? So this is actually the Netica window. So before going directly into the window, I'll let you know how to download Netica. So if you go to the Google screen, you just type download Netica software for Windows. Download Netica software for Windows. The company name is Norsys. Download Netica, right? You'll be getting this. This is actually the thing, right? The main thing around this is this actually support more in desktop rather than in mobile phone. So that's what the difficulty here. But so only we didn't include this in the experiment-based evaluation. So here you will be finding Netica for MS Windows. So for all versions of Windows, you can actually here and you can download this software and you can install it. So this is actually the Netica screen, and if you install it, you'll be getting something like this, right? You can install later, but here in this particular session, I'll be letting you know how to work on with this Netica version, and this is a purely commercial software used in industries. We are going to use unlicensed version, so some features may not be there, but it is enough for us to do our own simulations here, right? So what I'll do, I'll be going to the file menu. Can you see the Netica screen and the things what I do here?
Yes, sir.
Yes, I go into new and create a new network. And this is actually the network screen, what I actually have. I maximize it. So this is my work area. And if you see here, many things are actually available here. And the things of interest for us is going to be the nature node. This is, and we have decision node and we have utility node. So these three nodes are actually here. And as of now, and based on our syllabus also, we are going to work on the nature nodes. So nature nodes is nothing but I just click it and click again in the workspace. I get this, and here I got one node, and I click again this, and if I click here, I'll be getting another node. I just drop it anywhere so that I'll be getting some good structure. Similarly, I click it again. I drop it over here. Like this, I can have several things. Now, let us understand some scenarios and use a conditional probability for this particular Bayesian model. So, what is the scenario I have here is, yeah, how many of you know horse riding here? Horse riding in the sense, I'm not asking you to ride the horse, but you have seen horse riding.
Yes, sir.
Yes. So, what are the parameters for the horse to run faster and win the race? So, assume that I have a total probability. Say, if I double click it, I can open it. If I double click this, I will be opening this. So, I have a race stage. I'll be giving some race state. Uh, Horse win or lose. That is actually our horse race is result. Horse race result is going to be the thing. So name should not have any spaces, but title can be in having any spaces on it. But name should not have any spaces, right? So I just click OK. So I have this horse race result. And here, what are the parameters that are conditionally going to influence the horse race state? If you see, the power of the person who is riding the horse matters a lot rather than the power of the horse. If he does anything wrong, then the horse will not follow the path of the race. It will be jumping out of the race. Do you agree with me or not?
Yes, sir.
Yes, sir.
Yes. So I'll be saying rider strength. Rider strength. Yeah, I'll be describing here strength of rider. So I just click apply and OK. Right. Another thing the horse can actually do is the horse legs, horse leg power. Usually, a horse leg will be long and it will be having a high power. And the horseshoe, if you see, it will be as tough as possible so that it will run fast. Right? Power of horse. Right? I apply it and then I click OK. Right, so these things are there. Now, which are the dependencies and which are the independencies? These two are going to influence horse race result. Am I right or wrong?
Yes, sir.
Yes. So I create this link, that is the dependency link. I just click here and then I find who is going to be depend on whom. Strength of rider is going to influence horse race result. So I just click that influence result over the horse race result. Similarly, just a minute, it is actually working slower.
Horse race result depend upon strength of rider over of horse. Sir.
Yes. Just a minute, it is actually working slower. Just a minute, I'll close and open it again. is limited mode. Open it again. A new window. A nature node. I put 3 nature nodes here. Let me interconnect them through some links. Yes. We already have some scenario. And let me put that scenario here. What is this?
Strength of the race.
Data. Okay. And this is leg power. Power of horse. Right? Okay. And this is
Race result.
race result. Horse race result. Okay. Now we have the dependencies ready. Now we need to give the probabilities and automatically it will generate and give us the results for the different probabilities. We can extend this Bayesian networks to any higher level networks also. Let us start with some basic networks and then we can include some more nodes and make it different. So now what will be the thing is, now let me give some probabilities for this. So for this, what I'll do is, I'll go to the description and I'll change it to states. I'll give it different states. So what will be the race result? Race result can be win or lose. I have 2 states. I apply and I click OK. So there are 2 states. And strength of the writer. Strength of the writer can be strong, medium, low. Right? Okay, okay. And power of horse. High, weak. I have 2 things. Okay. Apply. Okay. I think it's in the description. Sorry. It should be changed to states. High, weak. Right. So we have it ready. Yes. So now for this, if you see, for each of the individual probability terms, it has assigned some default probability that is actually equally divided between all the possibilities. Strength of the writer can be strong, medium, and low. For all the things, it is already given some probability, say 33.3, 33.3, 33.3, totally according to 1. Similarly, here also totally according to 100, 100. So it has given the default probability. Now I can also change this probability based on the question given to me. How to do this? I just go to here in the table. It will be giving me what are the possibilities you are going to assign for those individual things. It itself says, you can see here, hence it is dependent on 2 other things. See, if you see here, horse race result is dependent on strength of rider and power of horse. Strength of rider has 3 possibilities and power of horse has 2 possibilities. So for strong, high, strong, weak, there is 2 things. Medium, high, medium, weak, low, high, low, weak. So totally 6 different possibilities are there. That 6 different probabilities, it is automatically identified and it is stated here. And for this 6 different things, what is the probability you want to give here? That's what we want to state. So for here, I'll be giving some probabilities. If the rider is strong and horse's power is also high, then I can say 100% I can win the particular race and 0% lose. And if the strength of the rider is low and the horsepower is also weak, so 100% I can have a possibility to lose. This is what the so here rider strength is there and the horsepower is not there, then I can say that I can have 70% to 30%, and similarly I can give here 30 to 70, and if it is medium and high I can say 80 to 20, And if it is like this, then I can say 20 to 80. Like this, it is actually a random thing. I apply this and I click OK, right? So this is what the term I have given. I have arranged this to, if you see the table here, it will be getting updated. The table values, everything is ready, right? Similarly, here also, I can actually change the values and keep. Or after running also, I can keep the values. Now, can you understand how the values are set? In the question itself, I said probabilities will be given. Likewise, we can just substitute that here in Netica and you can get the result. Now, if you see here, here I'll be getting some cloud-like icon that is called as compile net. The compile the network icon. I just click this compile network and I'll be getting some results over here. And this result states how the win or lose is going to be getting affected. Now, if you see here, I just click this and I try to increase this to anything. Here, if I increase this, what happens? See, automatically horse race is increasing. Why? Because I have set the probability table for horse race result dependent on strength of the rider and power of horse. And if it is the medium probability is high, then based on that win loss probability will also increase. And if I move anything like this here and see for this also, it is actually changing. Now it is actually medium here and weak here, and it is actually giving some probability of winning say 44.3 and loss say 55.7. And if I increase it even, it is actually changing. So this Netica software will actually give us the conditional probability in direct simulation effect. We need not apply any formula, anything. Automatically it will give us the results. Here we have only 3 nodes. We can have 300 nodes also. And for those 300 nodes also, very quickly this Netica software will give us the results. Now if you increase this to anything and automatically see when the strength of the rider is low and weak, see 77% lose.
Sir,
I
it
try
will
to increase.
Bayesian network, sir.
Come
Not
again?
semantic. It will default take Bayesian network, sir.
Yes,
Not,
they defaultly use Bayesian conditional probabilities.
not semantic, sir.
No,
We
no,
cannot use
no, no.
semantic.
You don't compare semantics with Bayesian networks. Bayesian networks are the next level to semantics. Semantics are just knowledge representation.
Orange representation.
This Bayesian networks is nothing but they are going to derive new knowledge. Here, the thing is you are given with strong, medium, low, high, weak only. You're given with some probabilities. And how you are, and it is actually judging how or who is going to win the match. It is going to predict and give you. This is new knowledge, not existing knowledge representation. It is actually finding some new knowledge. Now, this Bayesian network is actually another way of statistical machine learning, I can say. Am I making, have I answered your question?
Yes, sir.
Yes. Right. So we can also include the more number of nature nodes here. Can you say me some scenarios? When the horse wins, what will happen?
Rider also wins, sir.
Either wins, okay, but any
Prize
scenario like
money.
what will happen?
Prize
Treat,
money.
treat,
It's famous, sir.
treat, treat for friends and states. Huge. I can say yes or no, right? And what else?
Sir, it's famous, no, sir.
Famous
You will get money.
popularity, popularity of rider, right?
High, low.
Medium, low.
Sir,
Anything
sir,
else?
Prize money.
Prize money.
sir, it is our future, sir.
Yes, you can give anything.
And that are high, medium, low. We can give 4
Yes.
hours, 3,
Hmm.
2. Okay.
You want to give poor, poor,
No, sir, I'm asking.
good, average, poor. So let us write the dependencies here. So this is going to depend on this. Some complex networks. Now we can actually set the probabilities for this. Go to the table. Now it is having two probabilities. Now you say what probability I can give? What is the probability if he wins? He will give some treat. 75, 76% he will give the treat, and 24 he will not give. And over here I can give how much percentage he will give. Lose also he will give a treat. Huh? No, 5% and 95%. Yes, the table is ready with this, and I'll close this. And for this popularity, once he wins, how much popularity he'll give? He'll gain high. How much? 50 percentage
80%.
high, 25 percentage low, and from the,
25 low.
or I can give some 35 to and 15. I think totally 100 came. Okay, yes. And if he lose, also he'll get popularity. No, he'll be giving some 25, 30, and how much ever? 45. And prize money. If he wins, surely he'll be getting some good prize money. 15 and 5. And if he lose, surely he will not get that much good. He may get some average and 40. Yes. Shall we run this again?
Yes, sir.
Yes.
Yes, sir.
So I get something here. Now automatically everything will change. Now let me make it strong. Yes. So win percentage is increasing. When win percentage is increasing, treat 65 percentage treat is assured. 46 percentage will be popular. 69 percentage will get some price fund. And if it is weak, oh, everything is changing, right? So you make the network as complex for any different scenario. At any different scenarios, you can make as complex networks as possible, and you can identify the condition probabilities. You can enjoy the condition probability. You normally know some scenarios, and you have some probability ideas also for those scenarios. Say, for example, you take a traffic scenario. In traffic scenarios, if a person is not following traffic rules, and if a person is riding faster, what is the probability of getting him in an accident? And after getting accident, whether he will be going for a hospital or whether he will be going for any other thing. So you develop some scenarios, and you update that scenarios like a Bayesian network, provided that you can have a desktop, then only you can do it, right?